Hi everyone, I'm Stefano Moret from Imperial College London, and together with Gauthier Limpens from Université Catholique de Louvain, we're happy to present you today our EnergyScope model, as well as free applications and the corresponding insights for policymaking. As a brief introduction to our EnergyScope model, in a nutshell, it is a bottom-up whole energy system model for regional and national energy systems planning. It optimizes the design and operation of an energy system with an hourly resolution over one target year, and in particular, it has a particularly concise and appropriate resolution in order to be able to consider uncertainty in the model. As you can see here on the right, it has been already applied to different energy systems, such as in Belgium, in Switzerland, in France, Germany, and Italy at different stages of maturity. And if you want to get started with this model, we advise you to check our paper, to fork and run our open source code on GitHub, and to follow our developments. We try to regularly post updates on Twitter with the hashtag EnergyScope, and you can also follow our Twitter accounts. And of course, get in touch if you're interested in using our model. As a first insight and application to policy making, we applied the model for a comparative assessment of all the different conversion pathways for woody biomass. As you can see here on the right, we can convert biomass in different ways, such as we can burn it or we can convert it to biofuels and so on. And the first result is that the conversion of wood to biofuels is the most efficient pathway, but only if we link biofuels production to efficient end-user technologies such as cogeneration and heat pumps. So we have to contextualize the conversion of biomass within multi-sector whole energy system models. A second insight is the importance of electrification and sector coupling. In this case, we have applied the EnergyScope model to the Belgium energy system for the energy transition in order to evaluate the trade-offs between electrification, energy efficiency, and renewable fuels. And what emerged from our result is that to reach the energy transition, we have a high increase of electricity production, also because electricity is also used to supply heating and mobility with heat pumps and electric mobility and sector coupling. Renewable fuels will then be the missing stone to achieve the cheapest energy transition. As a last insight, briefly, the importance of uncertainty, we have applied robust optimization to this model. And as you can see here, we have tackled the aspect of overcapacity in European power systems, and we can show that considering uncertainty can dramatically impact strategic energy planning decisions and can reduce the risk of generating overcapacity. So this was very brief, but of course we have all the references in the slide, and we do invite you to get in touch with us if you are interested in applying our EnergyScope model.